Hello everyone, and welcome to the video talk through for From Social Science to Data Science by me, Bernie Hogan. This is Chapter 7, Accessing APIs, including Twitter and Reddit. So the learning goals for this chapter are to understand what an API is and why they're useful, to be able to get and to use a token in order to get data from a server. We want to appreciate how wrappers can be used in order to abstract away some of the API details and treat data on a server like a Python object. And we're going to see how to create bespoke queries for Twitter using the V2 Search API or the version 2 Search API. And I have a little asterisk here. I'm going to say to critically appraise what features of an API are available and for what purpose. And the asterisk is because I'm not actually going to be covering that in this video, but that's going to be at the end of a kind of a longer video on research ethics that will be kind of in between chapters 6 and 7. So the World Wide Web is not a series of static web pages. Often data comes down on demand through specialized URLs. The total set of these URLs and the parameters that you can vary, they comprise an application programming interface, or an API. So we talk a lot about APIs out in the world, and certainly in the world of social data science or computational social science, and really much about on the web. And they're not really that mysterious when you think of it as just a series of URLs, and those URLs are not just like a fixed URL, but they have special different paths, and each path, called an endpoint, allows access to data that's related to that path. Now you can have parameters, as we say here, and those parameters allow you to specialize some things about that path. Maybe you only want the first 10 items, or you want items in reverse chronological order, or so forth. So all major websites have at least internal APIs for translating or transferring data, because you wouldn't really want to render a bunch of static web pages and send them around the company. Now, most platforms offer at least some APIs to the public. Now, who gets to access what API can define knowledge about the platform. You'll see that in the platforms that we're using later, and where some things are either available, not available, or not available under certain circumstances. Now, while web scraping can accomplish many things, it's limited by speed and complexity. Now, APIs usually just give us the data, so we don't get a bunch of HTML to parse through, some JavaScript files we don't need, images or so forth. We know exactly what we're asking for from the server, and that's what we get. Now, thinking beyond the interface, something, I guess a trope at this point that I've mentioned in the book, really lends itself to considering the social web as a collection of APIs. So now, if your work involves more than just pre-chewed data sets, being able to be proficient with APIs and to understand their limits is really, really essential. It can help enable you to see features of a platform at very different scales from what you might be able to see as a user. This can include all sorts of distributions over time, or looking at a network of who is connected to who. But these are not necessarily obvious from the platform, even if the data to create or to understand these things is available from that platform. So now, one of the important things to consider with an API is that the purpose behind it is in many ways to give specialized or granular access to people or to users, to clients. And so that selective access requires a client in order to identify itself to the server and do that in some way that's secure. There's a variety of approaches for this that are both they range from like really, really simple to definitely more complicated than what we can cover today. Most of them involve keys and tokens. So sometimes those terms are used interchangeably, but really a token or a key refers to something per project. So we're going to create an app on Reddit later on, and it's going to have a key, and the key is going to be for the app. Now, you can have multiple apps on your Reddit developer account, and so each one of them should have its own key. Keys can be public or private, and often the mixing of a public and a private key using some algorithm creates some encryption that allows a client and a server to talk securely. Now, tokens, on the other hand, are per user. So you might get a token, and That token will be for you for your access to the website. Now, normally with those sorts of tokens, they are not stored anywhere that you can access easily. They're often just like shown for 1 minute or shown for a second or shown till you copy it. And then you would put it in your own program and send that along in order to request data from the server. Now, they're a lot easier to work with, but there's a real obvious security issue right there. There's no sort of like two-factor authentication type of system with a token. So if someone else has your token, they can just say, "Hey, it's me," like having your driver's license or something. But there's no picture on it. It's just here you go. So you're going to want to keep a token secure if you're using it. Now with the keys, of course you're going to want to keep those secure as well. But often you'd be using those through a library or a package, and then the package will tell you where to enter that key when you initialize to get your script ready in order to download data. Now, when you do that, it is possible to use keys through the OAuth library. I've done it for a few websites. It often requires a callback URL, and so for Python that can be a bit tricky. There's some cute blogs online for showing how to create like a little mini server in a script in order to be the callback URL and so forth, but it can be a bit fussy. I do think that it's very much recommended in order to find a Python package to manage the authentication process. So we'll see that with Reddit, and I guess at the end of the lecture I'll recommend Spotify and see how you can get on with that as well. Now those credentials, what do you do with them yourself? I've seen all kinds of approaches to managing credentials, some more secure than others. And I do want to pause and think about it for a little bit, because sometimes people don't take it seriously as part of the workflow, and that can lead to, I guess, some real security issues with your work. I mean, something you'll want to do with your work, or very possibly want to do with your work, is share it with other people, share the code with others. Now, if you have your token hard-coded in your code, then that's going to be a problem. You won't be able to share it with people without just giving them the token. So what do you do? Well, some people might write it in a text file or something, but what I prefer, and having investigated a number of different approaches, I really like this approach to using environment variables. Now, your computer will have all sorts of environment variables all over it. Say, for example, there'll be an environment variable that will tell the operating system where to look for Python when you type Python. Now, all those settings are available, and you can add to the environment variables. And in Python, you can do that with the .env library. So you may need to install this library yourself. When you do that, you can create your own environment file, or a .env file. And then you can add that to the operating system's variables. Now, it's only going to be available for the operating system's variables while that Python kernel is running, but you can then use that in your project. Now, why would I do it that way? Because you have this .env file that you refer to. The keys that you use for that file should be the standard keys, and then when you pass your Jupyter notebook to someone else, then you don't need to put your keys in the file. They can use their keys, or I guess you can transfer it through another manner. This is also very useful for if you're managing your work on GitHub, especially if you were doing this in a public GitHub repository. So one drawback of .env is that it doesn't use path objects. We can't pass it currently a path object. I'm sure that that'll happen in some future iteration. But nevertheless, once you do that, you can set a new key which you're going to add to the environment. You can load the .environment file, and then that will load all those keys that have been set into your operating system's environments. And then you can use them in your API requests. So that's where we're going to start today in the Jupyter Lab notebook, is have a look at some real simple APIs, and we're going to look at how to put a key into the .environment file. Okay, so once again, as usual, I say we should go up here, restart the kernel, clear all outputs. And we see here identifying ourselves. I'm going to start this up. Now you'll notice here I revisit this this website from the last chapter where we got a URL, or sorry, got an IP address, And just noticing there, this is an API, but it's just like that's as simple as you can get for an API. But it is an API. Once again, you have a URL that you can go to request data, and it doesn't really take any parameters there, but it still works all the same. So now you can see here I used an example of the cat API. Now, the reason I use this one is it's been around for a very long time, very simple, and if you register for it, it will email you an API key. Now, these aren't my actual API keys, but where you see letters, there was a letter, and where you see numbers, there was a number, but it could have been any number or any letter. But I just did that so you can kind of recognize the shape of an API key in case you get one yourself. So if you do this and you put your own API key in there, then you should be able to get some results back. Now it's worth noting one of the reasons why I chose the cat API, and it might be a bit, I don't know, a bit of an illusion in some way. It will return you data without an API key. It's only that there are some calls that you can do through the cat API that request that you have in your own API key. So it does allow us to maybe screw that up a little bit while still getting some data. But you should try and then explore the rest of the cat API because they have other endpoints other than this one right here, which will be really useful if you have an API key. Now, one important thing about this, and this is what I mentioned about .env, is how do we store them? So here we can see I imported the OS library, and in the OS library, that's where you can query the existing environment variables. So we can see here what's the environment for Python, or at least for this version of Python, and this is where on my computer it would go to find it. So now you see here I've commented out this install.env. You can uncomment that to install it, or use the kind of longer install where you look for the sysexec file that you've seen elsewhere in the book, but that should work. You'll also notice that what I don't do here is instead of path dot current working directory dot parent, that actually all can be wrapped into dot dot. So dot dot os.sep, and that once again does the / or / thing, dot env. So that's going to see there's going to be a .env file just in the parent to this directory, wherever this one right is here. And you can see that's right here. Here's the book. So at the top of the book there, if I click, there should be a .env file there. Now, as you'll notice, it doesn't show up, but it's also, that's because it's hidden because it has a dot at the beginning of it. If you go into Finder and you can change the settings, you can see that .env file there. But nevertheless, we'll be able to make use of it. I'm going to run that. It should be fine. And I'm going to load the .env file, and we'll see what the cat API key is right there. So that's my actual key for the cat API. Now, if you didn't get or if you got an error, then maybe you didn't actually set the key. So remember to set that key there so you can have the API for that cat. All right, so now that we have this environment variable, we can make use of it. So instead of putting the API key right in the code, we can just say headers.update API key and then get this environment variable right here. So just run this code right here. It'll have the API key in the header. Check out the request, and you should be able to check in the request.headers that was one of the headers that was sent up. And you can also notice we get some content here that we can query. It's JSON and that sort of thing, and we look at the temperament of, I guess, the Norwegian forest cat. So now shifting from just any old API, and now that we have an environment set up where we can add some keys or tokens, let's have a look at Twitter. So Twitter has a really well-used API for research. They have a lot of means for supporting academics and academic work, and it seems to have paid off for Twitter, as in computational social science, there is an awful lot of work on Twitter, and a lot of work that's just repurposes Twitter in some interesting way. So now, in order to do this sort of work on Twitter, you would need a developer account. Now, it's not that difficult to get a developer account. Effectively, you just need to have a phone number. I believe there might be other ways of doing credentials, but yes, if you enter a phone number with an account, then it will allow that to happen. So now Twitter has multiple tiers of access. So the free account should be totally sufficient for this lecture, but you may want other access. Academic actually allows for pretty generous access of about 10 million tweets per month, a number of other sorts of Twitter calls. And you also get access to the full archive search of Twitter. So all of Twitter going back to, I guess, 2008. If you structure your queries effectively, you can get all of it that's there, as long as it's still on the site. Now, enterprise access is more for businesses, and it allows also access to what might be called the fire hose, which is where you can get a lot of data coming in from Twitter at any given time. It used to be the case that you would get all of Twitter through that sort of access, but I don't know that they do that anymore. And by all of Twitter, I meant every tweet that would be tweeted at any given time would come through Firehose. Those are varying accesses for the streaming API, as in we're going to open up a stream and get some stuff in. But in this case, we're going to use the search API. It's a little simpler, and it's the archive from the past. Now, the regular access only gives you, I think, access to the past week for search results, and limited archive results for any given person or account. So if you go to an account, you can only get, I believe, the first 3,000 of their most recent tweets. But nevertheless, it's still enough to navigate the API and get ourselves used to that system. So now, if you wanted more, you would have to get the academic tier, and you'd have to apply for that. And it's worth noting that academic access is not guaranteed. When you do, you should consider clearly stating a project goal, having an active account, and providing credentials. Now, for what it's worth, it's been hit or miss with my students. It hasn't been 100% on the academic account. So in that case, it's worth noting to have an active account, as stated there, maybe name, face, that sort of thing, as well as clear project goals. I'm just exploring the API might not be sufficient. But try your luck, see if you get it, and if you do, then you have really extensive access to the prior archive of Twitter. So in order to do that, in order to get just any access, we can go to developer.twitter.com while we are logged into Twitter. And when you do that there, then you get this sort of page right here, developer platform, and I'm sort of obscuring at the moment. Right over here in the corner, we can see there that it has a thing, and it says sign up. Oh yeah, and it's interesting that it says sign up there because, well, I'm already signed up. And so it'll say that, and even if you are signed up, you click on that, and that will like shift you right over to the developer platform. Now on this account right here, we have this this might be what you would see, something very simple when you register. I'm not creating a fake Twitter account to register for another app, but you can see here is a very simple account right here that has just, well, consumer keys, authentications, and tokens. So now from that page there, and we'll see this now in a second, you can get a thing called a bearer token, and that's the single token you get for academic access. So be careful with it, and how to work with it. So I'm not going to bother too much with some of the details here. Bearer tokens are really useful, and we're going to get one. One feature I did want to mention, because I don't really highlight it much in the book, but there is some in the code on the website. So there's a similar feature for app passwords from Google. So if you have an app such as Python where you want to send email, you can use an app password from Google, which is like an environment variable, and will only be useful for one application. If you try to use it in multiple applications, I think it tends to just stop working. And it's only shown once through Google's app passwords. You have to copy that and put it in your application or set it in your environment variables. And then you can use through Python a Gmail account in order to send out mail, such as sending out mail in case there's an error with a script that you're running. Now, it's also worth noting that once you have this bearer token, which we'll see now in a second from the developer account, if you do have the academic access to Twitter, then there's a really nice downloader for Twitter. You kind of just like enter in the query, set the stuff, and it comes down as either a JSON or CSV file. Now, I have noticed, having downloaded or trying to download through the downloader, that if you're doing kind of hierarchical or nested work, where you want not just the tweets, but also maybe things about the users as well. If you get the JSON, it's not the easiest JSON to work with. Now we'll see more about that when I show the different kinds of JSON that come down from Twitter, but it is worth noting that while it says it's a no-code tool, that's only up to the point where you have to wrangle the data, and so then you're straight back to code. So in my world, I think it's not a bad idea to start from scratch and really build it up yourself, and then you'll know what you're doing with it. Okay, so we have here a bearer token that we can get, and now you'll notice there's no like view bearer token, it's just regenerate. So if we regenerate the bearer token, which I will do here, now you'll notice here is my bearer token. It doesn't even show it on the full thing on the screen. I'm going to copy it. Now let's go over to Firefox, and I'm going to add a bearer token here. You can see I've already been working with one right there. And I'm not so worried about showing the bearer tokens here on the screen, because I'm just going to regenerate one again after the video is over. And let's just delete that there. Okay, so I've run this. I put that in the .environment file, and we're going to print the bearer token. Now have a look. You'll see, and I'm actually going to print the bearer token itself. And the reason I'm looking at that is because sometimes the environment doesn't quite refresh. Now let's compare. See the end here, 9QN, and see the end up here, 1MN. So that's a bit of a trouble right there. Now there's a couple different things you can do with this. I've tried to myself do different ways of refreshing this, but when in doubt, you can actually just restart the kernel. And the unfortunate thing about restarting the kernel here is that you lose all of the import statements and all of the variables that you've saved. So really, you shouldn't be setting the environment path, setting those credentials in the same script that you're going to do to run. You should be setting that in a different script, and then when you go to your next script, when it loads the environment variables, it should work fine. So now we're going to go up again and import .env and requests and that. Like so. Oh, and of course OS. Once again, this is why in a script, rather than kind of this sort of lecture-y type style, you'd probably want to have all your import statements right at the top. Okay, so they should all be loaded now. Okay, so when we go down here this time, I'm gonna pause. I'm gonna not set the key again. But let's have a look. We're gonna load the environment file, and now this time you'll notice that it did remember. So it set this, but what happened was that because it already loaded up here, it didn't refresh once we set the key. So just bear that in mind in terms of that sequence right there. You're going to want to set the keys first in like a different kernel, and then load your environment files. But once you've loaded it, if you start setting keys, it's not necessarily going to pick up on that, even if you try to refresh the environment files in the same script. Okay, so we have that, and we have our bearer token. I'm going to print that bearer token again just to confirm. And now we can see down here we have a really pretty simple script. Here's the URL. This is the endpoint for Twitter. This is where what our bearer token is going to be. So, normally in a script where we wouldn't have this stuff printed there, you wouldn't really see the bearer token. And now this is a header. Now this always tripped me up. You'll notice in the script itself, the script isn't authorization and then just the bearer token. It is the word bearer and then a space and then the bearer token. So you can see how I've inserted that there. Now I put a query in there, and the motif for the book, you guessed it, of course, is the Muppet Show. So had another opportunity to stick that in. And I say here minus is retweet. That's one of the parameters that you can set through the API. And this one right here is just like within the query. It's a query parameter. Now those parameters themselves are they're going to be added to the headers as well, along with the URL, and they all get pushed up to Twitter. Now, once they do that, and we get that response back from Twitter for this particular URL and header sort of situation, then we'll get a response, and the response will get a response code. We want the response code to be 200, but if the response code isn't 200, then we might have a problem, and we'll have to fix that problem somehow. And there's a couple ways we can do that. Now, first, I'm going to just make sure everything runs a-okay. Okay, good. Now, I think it did run a-okay, and the reason is because it printed the keys of the tweet. Now, why do I think that's okay? And that's because if the code was in some way wrong, then it would give me a different error code, and it wouldn't even get down to here. So let's watch this. We're going to try this. So you see this bear thing? Remember I mentioned? So let's just imagine you just put your token in for the as the value where authorization is the key. Now run that, and assertion error. What's these? There's an assertion error. That's the assert. Code 401. It's not authorized. Okay, because that meant the authorization was not formed very well. So I put bearer back in, and it should work fine. There we go. And there's a couple others type of queries. Now another one. Oh, I suppose maybe if I go yes, and this particular account will not have. So this is yes, I see. So this particular account right here doesn't have academic access. So what that means is that we can search recent, but we can't search all. So if I go to all right here, we should get another assertion error. There we do, and I bet that's going to be unauthorized. Yeah, there, 403, we are unauthorized. And the thing is that, so it says here, client forbidden, rather menacing. But it's because this access only allows to the recent endpoint, not to the all endpoint. So that's all fixed up again. It's the right endpoint and bearer. And so we run again, it should be a-okay. So now I'm just showing these troubleshooting requests. We saw the unauthorized one and the forbidden one. You can also get forbidden. I think it's forbidden when you run out of queries. So if you ask too quickly for data from Twitter, then it will give you that and tell you slow down. There's also resource not found. Maybe you don't have the right URL. So above I use search all, and then it was forbidden because it didn't have access. But if I went search book, it would be like, well, there's no book endpoint, and maybe give me a 404 instead. And the goal, of course, is to get this 200 code, which means that we got the data coming down. So the sort of data that we get down from Twitter, we can show it here in the code, but it's under this data key, and you'll see that I print that down. And now let's have a look at this. I'm not going to show some of the. I'm not going to spoil the surprise. Let you explore the actual data in Twitter yourself. But I'll give you a sense of what it looks like. And so here was the unnested JSON from version 1. And it's a bit stylized here. These are not the actual keys, but it looks pretty similar to this stuff. So you might have here a tweet, like it says, I'm a demo. And it's a location, Springfield, and the author is someone named Ralph W. 2004, and they've got 20 followers. And here we have another tweet, and it says, believe in yourself, and the name is Lisa Lionheart, and so forth. You notice that, again, we have location, also Springfield. So both Lisa and and Ralph here live in Springfield. Now, Lisa, I guess a few more followers or whatever, and those are like useful details about the user. Now, what happens if we get another tweet from either Ralph or Lisa? Well, if we get another one from Ralph, we get more of the followers. We get actually the same detail in each tweet. So as you keep getting tweets, if you get tweets from a lot of the same person, you're not just going to get followers. You might get, they're actually called entities, and you might get public metrics. The public metrics include followers, friends, likes, and lists, I believe. And so you get all of that in one go. And you get that nested under user. You might get other things nested under user again and again and again. So this is unnormalized JSON. This is the sort of stuff that we would have to wrangle by maybe just pivoting on author. We just go for each tweet, look at the author, and then make little JSON data frames out of each author and then stitch them together. Now, the v2 data is normalized. So if you go into tweets.data, then you will see that it's a series of rows, and each row is going to have the tweet, and it'll have the author, but it's not going to have the full author details. It just has the author ID, which allows you to link to the rest of the data. So then it might have these users table under tweets includes users, and then you see it'll have the name, and the name you can link to author. I'm not actually sure, it might be called author ID in the actual tweets. This is just stylized. And then that's where you get the friends. And so you only get that once for Ralph, even though Ralph has, 2 tweets over here. So if you get many, many tweets from Ralph, you still only got 1 row. So it helps to minimize the amount of redundancy that comes down. And there's another includes that you could do, in this case here for, location. And in this we just say City Springfield. But in fact, location might have, again, other details with it. And you only get that, you only need to get that once in the locations table, and then you use the key, there probably would be a key or something here, in order to link to the rest of the data. So it gets a little closer towards that sort of the shapes of data that is more tidy. And the tidy data further allows us to create data sets that are a little more structured and merge them as appropriate, but otherwise just take down the data that we need. And so you can kind of see that right here. It's all kind of repeated each one over, but over here, well, we just got enough for keys, and then we can just list off the non-redundant data in its own table. The other cool thing about this is that what we see right here, this looks very much like what you could do for JSON normalize. So yeah, indeed, it's not very hard to then just take the tweets data, use JSON normalize on it, and you got yourself a data frame. And then you have a separate data frame by doing the same thing for tweets users and includes locations. Whereas here, once you wrangle it, you get one data frame with some dictionaries nested inside, which itself is not very pretty. Now, to get back to the API tools that I mentioned earlier, what you get from the JSON from API tools looks like this at the moment. And so while it seems easier to not use the website, or sorry, use the API and requests and all that yourself, when you get the data back, it's actually easier with the v2 data than it is with the v1. So, I don't know, 6 of one, half a dozen of v2. So sometimes you don't want to get all the data itself, or it might be very slow, and particularly if you're doing a very large crawl over a long, or a large pull over a long period of time. In that period of time, especially if it's a very popular query or hashtag, you just might not be able to get all the data in a reasonable timescale. You get 10 million tweets a month on the academic. So while 10 million tweets per month is a significant amount of tweets, if you're trying to get all the tweets related to a World Cup, or all the tweets with hashtag BLM or Black Lives Matter, hashtag Me Too, it will be difficult to get all of those in 1 month, and it certainly wouldn't be possible. No, it wouldn't be possible in a month, and it's unclear how much time it would take. For some data sets, Twitter do offer like a chunk of data. Particularly, I do recall that they have one for all mentions of COVID already pre-packed up. But sometimes you don't even really want all the tweets. You just want to know when something was happening and how active things were, how popular a particular tweet was over time. So you can use the counts endpoint, and the counts endpoint has a number of parameters, but the most important one is the timescale. And so by default, what it will do is it'll give you the most recent week, and for that week, it will give you the count of how many tweets fill that query per month, per hour. It'll do that per hour, and then it'll have one more for the most recent, not quite a full hour. So if it's at 9:30, it'll have one from 9 p.m. back a week, but it'll also have one from 9 to the present, 9:31 or whatever. And then there'll also be in the result a second key, so you'll get 2 keys. You get data and meta, and in meta you'll get a key for the total tweet count, and that'll be the total for that week. So even within recent, you can really get a lot done, but getting used to the full text search and the counts, it's really easy then to get some nice numbers for how popular a tag was over time without downloading an awful lot of data. So, creative use of this can lead to some interesting trends over time, rather than trying to download the thousands or tens of thousands of tweets that might have happened within a particular window, just to, talk about how common it was. Okay, so now when we did the Twitter API, you'll notice I used the requests library. We constructed our own URL, which goes to that endpoint with its parameters and whatever, and stuff comes back. But sometimes you may not want to navigate the endpoints yourself. You may find it inconvenient, or you may find that there's some features that are just not so easy to do by constructing URL requests. Times like that, and generally speaking, using an API wrapper can be really helpful. If there's a platform that has some way of getting data down, there's almost always a wrapper for that in Python. They would normally be through PyPy, which is a Python package archive, and so you would just install them. You could install them with pip often. I wouldn't trust every package out there, but it's worth having a look. Again, being a bit judicious, seeing reviews and so forth. But there are a lot of official packages as well. So when you deal with these, when you deal with APIs through a package, you're often dealing with an object. So you might have a tweet object or a tweet API object, and then you say tweet API object, dot query. Put the query in there, and then the result, got, for result 1 dot user or result 2 dot text or something. And so that way it becomes a little more Pythonic as an object and can be pretty useful for your own work. So when you deal with APIs directly, like I said, you get these JSON, CSV type stuff you have to wrangle. You have to deal with the authentication process and come up with your own way to link the data. But with wrappers, they often, when you instantiate that object, say it's a new tweet object, you would put in your credentials and it worries all the authentication stuff. And then you can act on the data itself as if it was an object. Now this might lead to some really neat or creative ways to manage the structure of the data, and we'll show one later on which kind of motivates the use of wrappers rather than just raw APIs within Python code. And we'll do that with PRA, or the Python Reddit API wrapper. Now for those of you searching online for this, you'll notice that there's not only PRA, but there's also PSAW, or the Push Shift API wrapper. And Push Shift is a very large archive of Reddit data that is generally available to the public, so that you can see like historically most of what's gone on Twitter, or gone on Reddit. And there's also PMAW, which is like PSAW, the Push Shift archive, except it's multi-threaded, and so it can allow more rapid querying of Push Shift. But for now, let's look at PRA, which is what's there on the Reddit site itself. So now, if you consider a wrapper versus JSON or XML, we already sort of looked at that in the bullet points, but let's have a little bit more of a detail here. You can create a requests or session object. So you got to manage the authentication yourself, which could be easy or hard depending. And then you manage the query through parameters. Now this is what we did in the last chapter, which we really were working with the Reddit API. But we just said, here's a URL. And now here's how we change the after parameter in order to page through the data. So that is, using an API and using these parameters, just like this. And you'll also need to manage the workflow between requests. Like in Twitter, you'll notice that we had to manage, what's the response code? Is it 200? And if not, well, then let's do something. The data that comes down, we have to do something with it. And rate limiting, really important topic, because if you don't manage your rate limiting effectively, well, it could block you or revoke your access, and nobody wants that. Now, on the other hand, with the Reddit object, you would instantiate the Reddit object. In my code, I called it red. And it often requires you to pass some sort of authentication parameters, like in the object. So you go red equals pra.reddit, and then put stuff in there. And you'll see that in the documentation for pra, and to some extent in the code here later on. And you can manage the query through objects. And you go like red dot something. I have red dot hot here, which I think is the right command for getting the most recent stories from Reddit. Now, one challenge here, though, is that the objects themselves might be a bit hard in order to translate and wrangle. So you, on the other hand, what I said earlier about Twitter, it applies here as well. So with Reddit, it wasn't that hard for us to take a whole response, make it a data frame, and get a huge data frame with a really long number of columns. On the other hand, if you are doing this through a PRA object, it might not be so obvious how you take the elements and just put it into a data frame. And that's often because it doesn't give you an object so simply. It doesn't just say, here's the JSON. It may give you an object with a generator, and what that means is that it's going to, you can use it in a loop, but it doesn't have a fixed size, or it doesn't necessarily know its fixed size. And so instead, what you would do is just say, just keep giving me the next story, and it will give you the next story or give you the next piece of data up until it either runs out of data or runs out of time. In a way. So it can be a bit more abstract in order to work with these objects and wrappers, even though it can make some things simpler. So in order to register as a developer on Reddit, it might not be the most obvious, and it can only be done through, as I understand it, the desktop version. Reddit is changing their developer APIs even right now, so within a year or two there might be a V2, just like on Twitter, which you can go to. But in the meantime, you navigate to reddit.com/prefs/apps once you have an account. And then you can click on the bottom and create an app. This one says create another app because I created one, but I believe it might say create your first app, or something like that. Now you notice what I've done here. I've given a name. It's kind of changed that name actually. And I call it a script here. It says script for personal use. And it'll only have access to the developer's accounts. And that's really useful because that means we can simplify the authentication process rather than using an installed app or a web app. So this is an example script for accessing Reddit. I just gave it a description, and here's an about URL and a redirect URI. The redirect URL is not so relevant if you're only using a script. It's more relevant for the others, which is where it's going to redirect the users to once it's authenticated. So if you click on that and then you create an app, then you can see that process in action. So let's have a look over here, and I'm going to go to Firefox. And we can see here I've already done this. We can create another app down here. If I create an application, call it demo or something like that. And once that's done, then it's going to look like one of these up here. Now, these right here, maybe if I'll just refresh this page, you can see here it's quite small. You can have a personal use script, and if I go down to edit right here, you'll also see this secret key right here. Now, once again, it's a bit small, but I'm only showing this because I'm going to delete this app once this video is over with. Normally, you wouldn't show your secret key. And then if I go over to the API right here, I can import PRA, check which version I have. I'm currently using version 7.5. You might have a more recent version. And you can see here what I can do is I can set these keys in my dot environment and then load that. And once again, remember, if you've already loaded it once, it might not refresh the second time, so you really should be setting these first and then loading it. So my Reddit client ID kind of looks like that length. That is what we see over here. This right there. If you know, I can copy that. It looks something like that. It doesn't have as many letters and numbers, but it's around the same size, and that would go right in there in the client ID. And then in the Reddit client secret, it's this right here this time around, but you'll notice up here it's got an underscore right there, but it should be, once again, just this particular value, and you pop that right in there. And you'll also notice that I set my username right here as my Reddit user and put that in my environment variable as well. And the reason I did that is because then the user agent itself is not just going to be by user Bernie, it's going to be by whatever user is set by the environment variables. Okay, you'll notice then once I do that now, down here I instantiate a Reddit object. And then I go pra.reddit. It passes as parameters right here. So we're not setting up a request. We're just doing that as part of the instantiation of this object. And once we have that instantiated, then we can use that to get details from Reddit, like so forth. Oh my goodness. And then we'll see right here, we'll run that. And it says the hot post right now is miscalculation. And I don't know what that is. I haven't checked it. But that's the title of the post and by it's submitted. And you'll notice that if you do this, you can get like a lot of posts. But what we're doing is we're not getting JSON back and wrangling it. We're using an object, in this case, red.front.hot. So that's hot for the front page of Reddit as opposed to some other subreddit. Now I want to show something that's really neat to do through the PRA, but it's kind of tricky to do otherwise. And it's called building a comment tree. Now a comment tree on Reddit is on each story they'll have a series of comments, or could have some comments. The root node is the post itself, and then the children, the first level children, are all the just comments to that post, and then their children are all those replies. So sometimes those replies go down very deep, but they never actually reply to something in the past, or sorry, something in the future. So because you don't reply to something in the future, you don't really create triangles. You just have kind of like this tree structure of replies to another reply to another reply, and it's called a directed acyclic graph. Now, one way it's often taught in computer science courses in order to navigate a directed acyclic graph is to use a thing called recursion. Now, recursion's tricky to get your head around. It's pretty neat. Imagine you have a get comments function, and then for each comment, if the comment has children, you run the get comments function. And then if that comment has a children, you run the get comments function. And it keeps kind of doing that, and it recurses down as many levels as the comment goes down. And then once it gets finally to the end, if it doesn't have a child comment, then return comment data. And then it kind of goes back up the tree. So it's a neat algorithm to work. A good recursion algorithm will in fact go through the entire comment tree, but it'll be really slow. You'll have to call it every time. And then you have to build that tree together yourself and make sure that your recursion is running correctly. I mean, the worst way to do it is to not use this and go if level 2 equals then, and if level 3 equals, and kind of have this really long if-else structure. But this should get it done. But you know what's easier? Just using PRA. So we can go, comments.replace more for any given post. Here I have limit equals none, and that's because on Reddit, sometimes it says, do you want to see more comments? It'll only give you the first limited number of comments with just replace more for the comments, but the limit says, no, just keep doing that as much as you can. It does work, and it works very simply out of the box, and especially if you just want a quick first pass of comments, rather than going recursively navigating all of the comments, which could be very tricky. So let's have a look over in Reddit right here, and we see building a comment tree on Reddit. And so this right here is a submission object on Reddit. If we looked at it online, then we would see what post it is. And it's actually pretty easy to do that on Reddit. I know that Reddit can have very long names, but you can construct that with a shorter one, which is just like redd.it/ and then this right here. And so if we take this and put it to put that to Reddit, it should actually redirect to the story itself. Okay, and look at that right there. It's thinking about it. It's going to redirect us to that story any minute. Here we are, and what a surprise. More Muppets, you guessed it. And this is Frank Oz, the voice of Fozzie Bear and Yoda and God knows what else. But this is an Emma, or an Ask Me Anything on Reddit. So you can see here, the comments are threaded. See 3 more replies, 4 more replies. So it says that when you first pull this down, so if I was to get this as JSON, it would similarly have these, gaps in the comments that the replace more would need to flesh out. So we can see here the whole structure as a tree, and you can collapse that. This is one. The root node is actually just the story itself. So these are the top level children, we might say, if you collapse them all. Okay, so now let's have a look at that. Just red.submission, and that's the Reddit object. And also, so I showed you the short way to do it, but you can also see it's snuck right in there under comments. So comment / this ID right here, and that will get the post. But you can also go red.it / that, and it'll get you right there. Okay, we're just going to run that there. And yeah, it's going to show the title. I'm Frank Oz, and example post gets the comment. So really simple. We didn't need to worry about the URL. We just gave the submission object right here. And now if we run this, first you can see before, this is how many comments are in the object before we do the replace more limit equals none. Now I'm going to run that, and it's probably going to take a little bit of time. I wouldn't necessarily recommend running it yourself right away, but it should, when it's done, give us several hundred more comments by using all of these right here, these little do you want to see more replies, and fleshing them out. Now you'll notice we can cross-check up here at the top. It should say how many comments, and that's 1.2 or 1,200 comments. Some of them might be deleted, some of them might be removed by the mods, so that number is not totally specific, and the number you get back won't be as specific, but it should be similar. And it's still running. Now the reason it's still running is because the first comments was a pre-cached, here you go, here's all of the comments. But then when it had to go replace more, it had to do one individual query for each additional part of that tree as it goes down. Each one of those queries has to have a break of a second or two in between each one of them. So for that reason, stuff like this on Reddit where you're collecting the data can be a bit slow. Okay, so the script is completed. It took a few minutes to do that, and it collected kind of the remaining comments. Now, you notice interestingly right here, I've already run that right there with the length of the example post.comments, and it gave 466. Is that actually how many comments are there? Not really, which is kind of interesting in the way that that PRA works. But you'll notice now, if I go and get to take those comments, example post.comments, and turn them into a list, like so, what it does is it flattens the comments, because sometimes if the comments just have one comment underneath, it doesn't seem to count correctly in there. So let's look at that comment list, and then I'm actually going to look at the length of that list. And look at that, it's actually 1055. So it's not quite 102 as suggested there. I suspect that some of them have still been deleted, but I do believe that that's pretty much all the comments. So now we can go and look at those comments in that flattened comment list. And you'll notice that that list, it's a list of comment objects. It's not a list of comment text. And so as a consequence of it being a comment object, we can query it like a comment object, and it has a property called body. So the body is the text that someone writes, and so we ask, is Frank in that text? Is it like, hey Frank, hi Frank, Frank Oz is great, whatever. And so mentions is the number that mention Frank, and the length of the comment list should be 1055. And so we see here Frank was mentioned in 181 comments, or 17% of the time. And so it's a little bit more opaque than just getting the data and reshaping it, but it can also be really powerful once you know how to work with a wrapper in this way. So now it's kind of the end of the chapter and end of some of the things that we might want to focus on when working with an API, and it's already been a bit too brisk. And one of the ways it's been too brisk is that I've shown merely how to authenticate and get some data down. In the last chapter I showed paging, but we don't have the kind of the space right here to think about the whole data collection pipeline. But I did want to offer some considerations for that as you scale up the work itself and not just scale up what data you can receive. So getting a few requests is one thing, but are you going to get the coverage that you want? Do you want everything over a very specific time period? It could be a year or 2 years. Everyone who mentions something and so forth. Thinking about your coverage and how it relates to your research claims are going to be really important, but it's almost certainly going to mean collecting more data than what you might do in an exercise in this sort of scripts. So it does tend to require patience and attention to workflow. So one workflow matter might be robustness. What happens if it stops in the middle of the data collection effort? Now, simple solutions are often available. Things like, oh, we'll just keep writing it to a text file, or we'll save it as we go. But they're not always the most robust. And one of the ways that can be helped is by shifting to a server. And this is especially useful if you want to run something that might take all night. Getting all the comments from one story took us 5 minutes. 10 stories, well, I guess might be maybe around 50 minutes. Depends on the scale of the comments. But 10 stories is still not very much for Reddit. And so if you needed to do this for a long period of time, are you going to keep your computer open? What if it's a laptop and you have to take it somewhere? So there are ways in which you can manage this. One is to use a version control system. It's not going to run the code for you elsewhere, but it is going to make your code available to you elsewhere, so that if you check in your code in GitHub or another version control system, such as perhaps Bitbucket, you can then pull that code back down somewhere else. Where else, you might ask? Well, one is just generic server. I say server because I'm not being specific about the server here. One example might be Heroku. Your university might have server access itself, and the server is just a computer elsewhere. Commonly, you would log into a server through a terminal using something called SSH, or Secure Shell. So the terminal window itself is a shell. It's often called a shell. And then you can secure shell into another server. Now, it's going to just look like the terminal, but then the commands you're running will be commands on elsewhere. Now, if you leave that server, if you exit it, it can often shut down the things that you were doing on that server. And for that reason, I recommend checking out Screen or practicing with Screen. And that's where it's a handy terminal program where you can type in Screen, and then it will create a new terminal window just where you are. You run something, then you detach from that screen. So you're back into your regular terminal window, but the thing is still running in the background. And so then you can exit your secure shell, and you can log back into your secure shell, see how the program is going, and maybe check in on it in case it's a long or kind of continuously running program. Another way to do this that's a bit more multimedia is to use Google Colab or Binder. Now, I know with Colab, you can have it running in the background and just ticking away. One thing you will want to be careful of, though, is that it can cost money if you're doing this for too long, or using too many servers, or using too many processors. So it's a handy solution, but it may be an expensive solution if you're not careful. But nevertheless, you can, with Google Colab, there are lots of resources online to show how you can run this in such a way that you can close Google, close your browser, and then log back in, and it will still be running in the background. Okay, so here we are at the summary. Well, I guess pretty straightforward. First, access to the web requires knowledge of APIs, almost always. And I say almost always because, well, even if you're getting a static web page, you're still using a URL. And APIs tend to be just specialized URLs with different endpoints, but maybe with some extra parameters depending on the need. So granular or personal data often requires authentication, which can usually be in the form of a key or a token. Remember, a key is like per project. Like with Reddit, we registered, we got keys for different projects, or Twitter, where we registered and got a bearer token that we could use. Like so. And so we can simplify, near the end also, simplify Reddit's authentication by using a wrapper, in this case PRA. And I used a very lightweight example, but we can find a more involved one, I'm sure, if you check through the API documentation. And both direct API calls and wrappers should still be mindful of the API rules and good practices for scalability. Things like saving your files periodically and not asking for data too quickly. So here's some questions to consider for APIs. Well, the first one, it's a tricky thing to explore. One way it's tricky, for example, the Reddit objects that came back, such as comment, it's not necessarily obvious what the properties of comment are going to be. So how do you explore that? You can try the documentation. Oftentimes that works, sometimes it doesn't. You can try Stack Exchange, Stack Overflow, but it's not always obvious. Now in this case, use PRA and explore a post object. We got one there for Frank Oz, and then we got the comments for that. But can you query for the post author, for the post title? You should be able to do that generally, and certainly if you see it in a data frame, it's just a column. But how can you do that as an object in PRA? So it's a little exercise for you. And then try using a different wrapper for another program. So I think the Spotify API is pretty well developed, and the documentation is really clear. Maybe as thorough as Twitter's. Now, you can use the official Spotify Python wrapper. And so Spotify, much like the PRA wrapper, will take some credentials from you that you would set up on Spotify's website, and then you can send it queries to the Spotify object, which are like sending it to an endpoint, and then get some data back. So try to get it working there. There's a couple different simple examples for Spotify on their own website, and I give a couple in the book as well. Now, there are many API directories out there. One that I used to like was called Programmable Web, but as of late 2022, it's shutting down. Nevertheless, there's a number out there, including a public API on GitHub. That's just a whole bunch of things. Try to find an API directory there, and try to find an API that you can get data from yourself with the skills in class. Now, you can also, and here's one that I think is pretty straightforward, we haven't explored, and the reason I'm mentioning it is because it doesn't require any credentials, and that's Archive. So Archive is a place where people will self-publish scientific work, often works in progress, sometimes things that have been published, generally for published open access. They have a pretty simple API, and the user manual there, I thought was quite handy. And the reason is because it actually goes through, in the quick start, a lot of the things that I'm talking about here. First, you can see a pretty simple API query there. It's just this endpoint, and here's a parameter, search query, and the stuff about it. It kind of shows what the API is. Here's some ways in which you call it using get. And if the parameters are on long, a post request might be required, so you'll have to explore that. And here we have down here, it shows all the different ways you can construct your queries. It goes through paging, so just like Reddit, you're going to need to find a way to page through it, and then manage the order. When the data comes back, check it out. It comes back as XML, a specific kind of XML, Atom, but that is pretty consistent and easy to parse. But you should be able to parse it using XML to dict or just navigating through Beautiful Soup. And so we can see here that while I didn't construct this chapter with Archive in mind, having experience with different APIs, I can see how they're generally constructed. And so when going to Archive, all the skills that we need are almost all kind of there already. So have a look, see if you can get a distribution of a keyword from Archive. They show the example there of Electron, and you just get the most recent 10 articles. Can you page through it, checking that documentation out, so you can get a sufficient distribution of articles, and then maybe see what keywords appear within them, what is the distribution of years, and so forth. But that's pretty much it now for APIs. So I hope you are able to make use of them and go out into the world, get some interesting data, and make some use of it. And one of the things you're going to want to do with that data, make some claims. Now, what do we mean by claims? How do we get from making a use to making a claim? Well, often that's through a research question. And a research question is what we're going to cover in the next chapter, Chapter 8. Thank you for listening.